Hello everyone, this is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Today we are going to take a topic under physics. We are taking physics this time around, and the topic we are going to take is mechanics. So please, before we go into today's work, do not forget to like, share, subscribe. Click on the notification button to have more of my video. Thank you so much. Now, come over. The question we are going to solve is this. A particle moving in a plane or surface has its motion described by x is equal to 20t plus 10 and y is equal to 6t squared plus 40, where distances are in meter and times in seconds. Find the magnitude and direction of its velocity at instance of 5 seconds. But before we do that, the topic we are taking is called mechanics. Mechanics is divided into two parts: kinematics or kinetics and kinematics. Another word for kinetic is called dynamics. The dynamics study motion of a body. It study motion of a body and force F acting on that body. Force F acting on the body. So that means kinetics or dynamics is the aspect of mechanics that study the motion of a body as well as the force. Look at this body now. This body is at position P1, moving down to position P2 here, and the force F is acting on it. Let's say the velocity of this body as it's moving in this direction, the velocity is v. So as this body is moving in this particular direction, there is a motion. So when we study the motion of this body and the force, this F is the force that is acting on this body. This is the body. Then we are studying what is called kinetics or dynamics. Now, when we study the motion of this body, the same body that we have here, and the body is moving from point P1 to point P2. The body is moving with velocity v, and there is no force. There is no force acting. We are not considering the force. Let's say we are not considering the force causing this motion to take place. Then we are doing what is called kinematics. Now, dynamics is the study of relationship between forces, motion, and matter or body. That is mechanics. So far so good. That is the idea of this particular topic we are going to solve. Now, before I go into mechanics, there are three dimensions of motion. Three dimensions, or let me say three types of dimensions of motion of a body. The first one is 1D motion. That is the motion of a body along a straight line. This body now is moving along this straight line. When we study the motion of a body along a straight line, we are doing what is called 1D motion. That is one-dimensional motion. Now, when we study the motion of that same body on a surface, the motion of a body on a surface. What do I mean by surface? Let's say this is a surface. Now, it has dimension x and dimension y, and this body is moving on this surface. This is the body. I'm looking at the plan of the body. Let's say this body is moving on this surface. That is a 2D motion. When the body is moving on xy axis of the Cartesian plane, we are talking about 2D motion. Now, We also have 3D motion. 3D motion. That is the motion in space. 3D motion, that is motion in space. Motion in space. Like for instance, look at this marker. This marker is in space. So the motion in space like this is 2D motion. Now, this board that I have here is a plane. So all this ground, look at this ground, this floor is a plane surface. So you can see now, this is the, let's say this is the x-axis and this is the y-axis. So the motion of this body along on the floor, that's the plane, is the 2D motion. But if I'm taking the body on this straight line alone, this is 1D motion. Now if I take this body in space like this is 3D motion. And the 3D motion has 3 axes. We have axis Z, then we have axis X, then we have axis Y. Axis Y. So the body can be located in space. Let's say this is the body moving in space. That's the 3D motion. So these are the motion that we normally study fundamentally under mechanics. So I believe that you have an idea of everything I've written so far. So far, so good. Now let's solve this problem that I have here. Let's solve this problem that I have here. A particle moving in a plane surface and its motion described along the x-axis. The motion is given as 2t plus 10. That's the motion along the x-axis. So you must understand something concerning instantaneous velocity. When we have this one as what is called displacement, then change in displacement with respect to change in time is called the velocity. So if this displacement takes place along the x-axis, then we say dx dt is equal to vx. That is the velocity along the x-axis. If it is displacement along the y-axis, then it implies that velocity along the y-axis will be dy dt. Please take note of that. Then also take note of differentiation. If you have a function y, recall. We need to recall this differentiation. If I have a function y is equal to as raised to power n, then instantaneous change of this dependent variable y with respect to independent variable x is given as using this power to multiply. Then you subtract 1 from the power. That's the fundamental of instantaneous rate of change. We are going to use that on these terms that we have here. To find the velocity along the x-axis, we say dx dt. Then we are going to differentiate each term separately. The differentiation of this one means this power I use it to multiply, like I've explained up there. Use this power. This t is raised to power 1, so use it to multiply. So it's going to give us 20t, I suppose. It's going to give us 20t. Then differentiation of a constant, no, sorry, this one will give us 20t raised to power 1 minus 1. The differentiation of a constant is 0. So this can be written as 20t raised to power 0. T raised to power 0 is 1. So this one is simply 20 meter. Because the dimension given are in meter for distances and time for time is taken in seconds. So 20 meter along the x-axis. Then along the y-axis, according to the question given here, look at the question. Along the y-axis, the motion is given as 6t squared plus 4t. So along the y-axis, the motion is given as 6t squared, according to the question, plus 4t. So that means velocity along the y-axis. Here, please take note of this. I can rewrite this one as vx. That's velocity along the x-axis. So velocity along the y-axis will be dy dt. Like I said, use this power to multiply. This gives you 12. Then you subtract 1 from here. This one gives you raised to power 1. Plus use this power to multiply. This gives you 4. Then you subtract 1 from this power. 1 minus 1. That is 0. So you can simplify this one as 12t plus anything raised to power 0 is 1. 1 times 4 will give us 4. So now, we are given the instant. They say find the magnitude and duration of the velocity at an instance of 5 seconds. So at instance of 5 seconds, I can write it as at instance of 5 seconds, I write it as vx when the time t is equal to 5. means that anywhere you see t, you put 5 here along the velocity along the x-axis. That's it. And then here now, our this thing is a constant, so we don't need to substitute anything. That means the velocity at instance of 5 remain 20 meters. That means the value of the velocity does not change as regard the components of that motion along the x-axis. Now, along the y-axis, the velocity vy at an instance of when the time is 5 seconds. When the time is 5 seconds, we subtract 5 for the velocity here. So it's going to be 12 times 5 plus 4. 12 times 5 give us 60. 60 plus 4 give us 64 meter per second. So this velocity here is not in meter, please. Velocity is measured in meter per second. So this one is actually 20 meter per second. Now, this one now brings us down to the final solution. Now, you recall that when we have the velocity along the x-axis and the velocity along the y-axis and velocity along the x-axis, then the resultant velocity is along the common point joining the component. This is component along the y-axis and component along the x-axis. So along the y-axis, we have seen it to be 64. Along the x-axis, we see the velocity to be 20. So in a nutshell, the resultant velocity now, which is v, according to Pythagoras theory, you can see the resultant makes an angle theta with respect to 64, with respect to the horizontal axis, and angle 90 minus theta with respect to the vertical axis. But I'm using this angle theta to get the direction. But before we can do that, using the Pythagoras theorem, the velocity v square is equal to 64 square plus 20 square. So the velocity now will be square root of whatever we have here, 64 square plus 20 square. Whatever we have here, the square root of it will give us the final result. So I want to press my calculator to get my resultant velocity. So I will have I'm pressing my calculator, 64 raised to power 2, then plus 20 raised to power 2. So I'm having 67.05. So the resultant velocity that I obtained here is 67.05. So the velocity that I have here, v, is 67.05 meter per second. That is the magnitude of the velocity. To find the direction, we are going to use tan theta here to find the direction. To find the direction, we are going to use tan theta. And tan theta is opposite over adjacent. Tan theta is opposite. That's 20 all over adjacent. That's 64. So tan arc of theta will be tan arc of this. This 20 divided by 4, I think is 5. And 64 divided by 4, 4 in 6, 1. 4 in 24, I think 6. So if you take the tan arc of this, if you take this tan arc, I'm taking the tan arc, please. If you take the tan arc, let me write it somewhere here. Theta is equal to tan arc of 20 divided by 64. If you press your calculator, tan arc of 20 divided by 64. 20 divided by 64. No, sorry. Please, the velocity along the vertical axis is 64 here, sorry. And along the horizontal axis is 20. So here is my 20. Here is the velocity along the y-axis, 64. So that means what I'm going to have here is going to be 64 divided by 20. That is opposite over adjacent. Let me write this very well. Tan arc of, so my theta my theta is going to be tan arc of 64 divided by 20. And if you press the calculator, tan arc of 64 divided by 20, I'm having roughly 73 degree. That's, I'm having roughly theta is equal to 73 degree. So the direction of that resultant velocity here is 73 degree. Now, if you want to show this one on 4 cardinal points, I can place this something like this and put that 73 here. This place will be my north, this will be my east, this will be my west. So subtracting 70 from 90, that's 20. 20 minus 3, this place will be 17 degree. Another way to write the direction will be north. Direction can be written as north. They're moving towards 17 degree towards the east. So that is the direction. Or you can just say the direction is at an angle 73 degree with the horizontal axis. So that is the solution of this particular problem that we have here. I believe that you must have learned one or two things concerning mechanics. This is physics this time around, not mathematics. Once again, please do not forget to like, share, subscribe, click on the notification button to have more of my video. Thank you for your time. Thank you for the engagement. Thank you to all my subscribers. Thank you for all you have been doing. Thank you for your support. Have a nice day. Bye.